So to conclude this module, I want to talk about determine the best forecasting model to use when we are dealing with the time series forecasting. Okay, a visual inspection can indicate whether seasonality appear to be a factor and whether a linear or nonlinear trend seem to exist, right? Remember the analogy I mentioned. You don't want to give a 6-month-old a 2-year-old clothes. They don't fit, right? They don't fit each other. So first of all, you need to inspecting the data using the timeline plot to see, are you seeing, is your data stationary? If it's stationary, thinking about moving average and try out the exponential smoothing. However, if your data is not stationary, based on what learned in this class, you can try time trend model, right? If you see the seasonality, try the seasonal dummy variable into your model. Okay, and of course, if you are able to learn economic forecasting in the advanced class, and I actually gonna talking about more in-depth forecasting model and even a smoothing model. We have a smoothing model that actually can capture seasonality as well. However, but here, always draw the line plot first to identify the pattern. Okay, so now if you decide to use in the last part we learned the causal model, you need to draw the scatter plot as well to see if the time series and this causal factor have a strong relationship. Okay, so that means if a certain relationship appear totally random, this may lead to exclude a corresponding independent variable from the model. So when you work on the larger data set, it is recommended to divide the data into the training and the validation set. And we're using the training set or with a training performed on older data. So you don't want to train on the same data and forecast validate on the same data. So you pretty much just tell yourself building a model may end up overfitting the model. So based on the forecast arrow, you want to calculating the MAE, MSE, MAPE, and then so when you're calculating these values, you should base on the data set that are being left out. You didn't use that part of data to do the forecasting, and using that part of data as your measurement about how accurate a model can predict the data the model haven't seen it. Okay. So to summarize this chapter, so we introduced basic method for time series analysis and forecasting, and we first learn how we can recognize different kind of patterns, because it's very important, because sometimes if we miss the pattern, we might end up using the wrong model. And then we look at different kind of smoothing method. We're mainly focusing on the moving average and also the exponential smoothing. But keep in mind that for both smoothing method, your data has to be stationary. That means there's no trend, no seasonality, no cyclical effect. However, if you are dealing with the data with some kind of series trend, so we can consider use the linear regression analysis and using the period as your x variable. If you see the data had the seasonality, you should incorporating the seasonal dummy variables into your regression model. So at the end, I want to mention that if you decide to use the causal linear regression model, you should first draw the relationship between your x and y variable first to see if you see a clear linear trend between your x and y variable before you introduce to your regression model to do the forecast.